Okay, let me try this again. Hey, Hope.
Hey Joris, how's it going?
I'm doing fine, and how about yourself today?
I'm good. It's nice here in Boston in the Northeast. It's cold, but we're making our way through it.
Awesome that you could find some time to talk about data today, yeah? Especially because this podcast series is about Snowflake here with DBT, and we are encountering DBT a lot lately, and we've been using it for the past 5 years, I guess myself. Um,
Are you an early adopter?
Yeah, it's been a while. It's been a while. Really early adopter. I think you guys, or at least Fishtown Analytics, the company that turned into DBT Labs, they were five when we started using it, and it all started with a Python with a pip install DBT command at some day, and it was awesome to see the company grow. Well, actually, to see the company turn into a software company, and now to see it grow into what it is, like this ubiquitous technology that is basically going hand in hand with Snowflake for many reasons. Huh?
Yeah, and I think the sort of ubiquitous nature of DBT and where it's being seen everywhere really goes back to the business problem that DBT is trying to solve, which is data transformation. So, data transformation, it really is a ubiquitous issue, and what I mean by that is your tables are really never in the finalized form that you need them for your business insights or machine learning, right? So you need to create those pivots, those where filters, all that kind of stuff. And DBT really manages that end to end for your pipelines. So I think that's definitely why we're seeing it everywhere. And then when you think about how Snowflake and DBT go together, I mean, like Snowflake has also had like a crazy exponential rise as well. So these are really technologies that work well together, and they sort of click together really nicely.
Yeah, that's what we see about DBT as well. It's super focused technology. And so in the past, previous technology iterations, we used to have ETL technologies. And those technologies, they basically took data from system A into system B. And on their own servers, they started to transform all of this data. But that's a pattern that doesn't really apply any longer. Huh? And Snowflake basically is so powerful and so scalable that whatever workload you throw at it, as long as you have credits to pay for it, Snowflake will be able to transform it. And it seems like DBT really found a sweet spot and to make sure that Snowflake is able to basically execute whatever we want it. Is that also the positioning that you would give it yourself?
I definitely would, and it's also right. DBT kind of sitting on top of Snowflake in a way that it's actually managing the stuff that's maybe not been the most fun, at least for me, having been a data scientist for 5 years. Right, that testing, the documentation, the deployment, so that Git integration. So when we think about what DBT can do from that standpoint, and sort of the things that maybe sit outside of Snowflake, like DBT does not move any data. It's really sending all of that SQL directly, or Python now, to Snowflake. But it's really think of it as that SQL compiler and that workflow manager in a way to sort of get those data quality pipelines.
Yeah, and that's where actually our own field of interest lies as well. Huh? So you mentioned SQL. Snowflake is really good at processing SQL, expressing complex transformations and creating metrics using SQL. But SQL by itself, actually, it was not designed to be a tool technique to be used enterprise-wide. It was made to be written by analysts to answer one specific answer, and then move on. And it seems like DBT really has found a way to make sure that SQL can be used enterprise-wide.
Mm-hmm. I think there's a couple things with that though, right? Like the SQL of the 1980s is like not the SQL today. So there's a lot of innovation going on at Snowflake. When you look at actually the syntax and functions that have been added, there's so much more that you can do and do it in a performant way than you could when it was originally created. And then the fact that DBT is actually able to manage all of that and run sort of tests out of the box as SQL queries is like, it adds a lot of power to what you can do. So I think it's like, SQL, a lot of people say, is this really a language? It's declarative. But I kind of think of it as like a little bit of a Swiss Army knife. It can pretty much do most of what I need to do before dropping it into another language. And we think tabular still in a lot of ways.
Yeah. And I think you hit a very interesting concept over there at testing. Testing is one activity that actually should be done all the time by data people. But it's tedious, it's nerve-wracking, and it has to be repeated basically every time you deliver something, not only for whatever deliverable you bring to market, but as well for everything else you ever built. So like a mega tedious activity. Nobody wants to do it. And in the data engineering space, the BI space as well, the past BI space, we never really had a practice of doing that because of its basically heftiness and the weight it had on a project. It seems like DBT has found a way to basically guarantee the quality of transformations and data sets that have been generated. Would you say the same?
I would, yeah. I'd say as much as the DBT is doing the transformations, really what the push is that DBT is also a framework and best practices, and sort of this idea of getting data and analytics people to work more like software engineers. So like we're thinking about the scalability, we're thinking about testing all the time. You see that in unit testing with software. Instead, what kind of this looks like on the data side is actually, testing those values themselves, making sure they meet your assertions and assumptions. But like, I can't fault data people for not doing this when you haven't had the framework historically. So that's why I think it's like, thinking of both DBT as the tool to do that, to transform the data, but also putting together those best practices in that framework to just like drop in and enjoy the project that you're doing instead of feeling like I'm babysitting and nursing this pipeline along. That's definitely how I felt. But like, yeah, when data people haven't worked with Git as much, or there's not a testing framework in place, and maybe you actually have used Git, but you have a repo called ad hoc, and that's where you run all your data tests once a month. It's definitely not the same as, like doing that testing every single run. And so I think that's kind of what we're seeing the shift to.
Yeah, and basically we saw the same actually, and we have been experimenting with it for the past few years. And when we started off with DBT, actually we were looking for a tool that played well with Snowflake. Honestly, there was nothing out there back then, and DBT seemed to be very promising, but like very niche. And actually, after a while, we understood that it was actually transforming the way we work. So we used to work in a very waterfall-ish way, a very traditional way, moving transformations from system A to system B, executing it and hoping nothing breaks. And when something broke, we would have heard it the day after. With the whole workflow that DBT is proposing, we can basically reorganize it the way our teams work. And so the way a sprint is organized, the way backlog management is being done, the way stories are even written, and the way we communicate with our stakeholders during demos. And it's basically because there's all these little things, these extensions to what SQL at its core does, that DBT adds on top of that basically allows us to be like super sharp on delivering business value, I should say. It's automating away all of the overhead that we used to have in the past. And you can now, at least the way we work with DBT is basically delivering whatever was asked to deliver without looking at the past anymore, and making sure everything that was ever delivered still works.
Yeah, like it's the design phase and building is always fun, right? And like having to either like I said, nurse this pipelines long, or like debugging them when they break is awful. And it's terrible as a data person when that's when your stakeholder has communicated that to you instead of catching it upstream. So like a similar story is that like at the last organization I was at, working as kind of like a data scientist, but also an analyst because I was doing a lot of the descriptive analytics, we had SQL, Python, and Spark all sitting in one pipeline. And when this would break, it would be like an hour sometimes to find the problem. Like it could be 15 minutes, but it was at least 15 minutes to an hour, especially if it involved Spark. And then it was 2 to 3 hours of actually debugging it and rerunning it, and essentially making sure, when you open that dashboard, there weren't like a bunch of caution signs or errors. And so that was actually the point where we had decided, okay, it's what are we going to do about this? Because this isn't fun. I want to make new stuff. I want to create better insights. instead of having to essentially be support for all the analytics I had built. And I think that's kind of what it is really about unburdening the analyst and even the data scientist when we talk about DBT being used for like feature stores for machine learning models. But it's really about unburdening that support aspect of analytics in your organization because you trust how they've been built. You trust that when these things rerun, they're not going to break. And I think that's really powerful because, as you said, it shifts the way you work. And it's right. It's bigger than just a piece of technology or a pip install. The ease of adoption is a pip install. But then you start interacting with this and you're like, wow, it feels like clean and crisp and I'm actually enjoying this experience. So I think that's what's pretty special about it and definitely my experience too.
There's a buzzword for that. At least around here we call it data ops. So making sure that if you create a data set, that the whole operations of taking the data set from your own laptop into your target audience that may be spread across the world is basically automated. And that every time you push new updates and new features to your audience, that all of the operational work has been optimized. Huh?
For sure.
That's actually what we like about this neat interaction between Snowflake and DBT as well. Like Snowflake is improving all the time. As you mentioned, they're adding extensions to SQL that are super powerful. I think about data masking, think about data sharing, think about these extension points that DBT also plays into with with Python. All of these things are super hard to manage if you have to manage it within Snowflake itself. But DBT adds this layer of sparkle magic on top of it that makes it very useful and very tangible for teams to start working with and start scaling up with. Huh?
Yeah, I think it really helps solve the problem of where did I put this, right? Your tests are in the test folder in DBT, your macros are in the macro folder, all those kinds of, and the package management. So the actual project structure and organization, I think, has helped with that. As I take a step back and we're talking about all the cool stuff Snowflake can do, and you think about all the innovation, the zero copy clones and these immutable micropartitions, and we're speaking as data people and all these buzzwords. I think that though is what kind of can really make it intimidating. I find this stuff cool because I work in data every day. At the same time, I think that when people are trying to move from on-prem to cloud or they want a hybrid cloud approach type of thing, it's yes, there's all this cool new stuff that you can do with Snowflake, with DBT, but it's also really just about taking whatever your business is doing to create value and just shifting it into a more reliable infrastructure environment. So if you don't need to do data shares across region or zero copy cloning, you don't have to start with that. And then, as that problem emerges, it's great to then use this technology that's already been developed. But I think that's the scary piece. Even when you look at other cloud services, you do not need to use every service that these platforms offer. And so I think that's important to keep in mind is what does your business need just to get started to move to a more reliable infrastructure?
Yeah. And I think that's a big challenge for many businesses moving to the cloud or being just in the cloud and trying to ramp up their efforts. Especially because if you look at people, and there's loads of people in BI, ETL, data engineering from other technology iterations that have to be moved into something cloud native. And then these data projects these days, I don't know about the project you see back home, but at least here, data is really, really exploding. Projects are scaling up at a high pace. Many people who did not have data jobs before are now working with data, at least on a daily basis, sometimes even turning into data engineers. And yeah, there's a certain learning curve attached to it. And so a learning curve in terms of getting acquainted with Snowflake, getting acquainted with data ops, getting acquainted with testing frameworks, and so on and so forth. And at least one of the super interesting things that we saw over the past few years is that DBT can offer these guardrails, this standard predefined way of working that basically spans all of these fancy concepts and flattens the learning curve. And you don't have to be an expert in CI and CD and continuous integration and continuous deployment to basically automate all of your overhead work that makes you slow and makes you never deliver your deliverables in time. You basically don't have to learn everything about Git, which may be super complex when you read the Git manual. I think it was written in the early 90s. But actually is the core to automating all of the team efforts. You don't have to know everything in Snowflake. You don't have to have the passwords in Snowflake to do like very super sensitive, complex stuff that may cause data leaks, because that's even possible, and because DBT is handling all of that for us. I'm really liking that. I think it's a great effort, a great evolution, something that's spun up in the open source space, something you guys are now taking to market as well. Yeah, and it feels like it's really flattening the learning curve to adopt larger Snowflake projects for larger audiences. Something you see back home as well?
Yeah, for sure. And I think the thing that I kind of want to double click on is Git and the guardrails around Git. And so when data teams haven't used Git before and they haven't, like, everyone can relate to version tracking, right? It's like one of the reasons that we use Google Docs and we make those live changes, and we're kind of almost automatically pushing those changes if you think about it in that way. But when teams haven't used that, and I what I've noticed is that there's always like an apprehension around Git adoption, because you're worried about, if I mess something up, I may not know how to fix it because, right, I haven't learned about this yet. So I think one of the things that dbt Cloud does really well is it puts that guardrail around the main branch. And so like you cannot directly push to main, right? It's essentially a read only. And that avoids things like having to tell all your developers to stop and do, like, you have to do a head reset on the branch, and you have to then find somebody who knows how to do that. So I think it's like, lowering that barrier, getting that better, like, ease of adoption, having that framework to drop into, those are all really key. And I think, like, even though there's more data and it's getting more complex, you still see a lot of other tools that, like, with a reasonable amount of upskilling, you could have like one-person data teams at these smaller companies, because Fivetran and Stitch are ingesting your data, it's going into Snowflake, dbt is transforming it. You can kind of have it all within like a nice little data stack today. You can have Hex or Mode sitting on top of that or Looker for your BI space. So I think it seems like a lot. But then when I think about these breakages and these really like monolithic, huge issues, like as an analyst, I also don't want to think about like runtime issues if I'm running SQL or Python code. I don't want to think about servers, right? That's like the whole reason cloud existed in the first place. But it should, I shouldn't say should. I shouldn't tell people how they should feel. But I think it's like really an unburdening in a lot of ways, that there's some activation energy needed, but like the payoff is a lot better. And teams that have adopted this data stack and adopted dbt, like, we see them working faster. We see those people are the ones who are able to get promoted because their time to delivery is so much less. And we see engineers and analysts working together and speaking a lot more of like the same language, and they're actually able to look at the same repositories. So I think that's really powerful, is like, the engineers that really want to enable their analysts are the ones that do really well with this adoption.
I think you hit a lot of nails over there, especially the promoting faster part, because you're hitting your nails every time again, is an important one. I think much of it has to do with like this very smart combination of creating an open source technology, spreading it out in the market, making sure adoption is awesome, and then building a company on top of that, and making sure that company can handle enterprise requests, can handle SLAs, like these contractual things that are very hard to manage in a pure open source space, but on the same time as well, keeping like the ecosystem open. And so dbt, in my opinion, dbt is partly great because of its great community, like this super open Slack space where everybody's like open and everybody's allowed to join, and conversations are open and knowledge is being shared on one hand, and on the other hand, like, openness in technology as well. So we noticed that companies start building libraries on top of dbt. We have our own libraries for niche problems built on top of dbt, things that need to be developed once, debugged once, tested once, but then can be scaled across sometimes big companies. I haven't seen that before, honestly. I think this at least partly explaining the success of dbt.
I think the open source aspect is special in and of itself. You really don't see that a lot. the community that has like 50,000 people. I'm in there. So if you have DBT Python questions, I'm around, So, and finding people who are in a similar journey. So we have people who are just starting, but then we also have power users, and those people need different kinds of support. And I think the other thing too is it's really about like how comfortable do you feel coming into a setting and asking questions, and you need to be able to foster that, because maybe you forgot your trailing comma, but you're a data team of one and no one spotted it, and you can sort of drop that in the community, or like you're missing your trailing comma, right? That's like a beginner issue. But then you have people asking about like schema name changes in Snowflake when you're using Python, and sort of like known bugs, and they're pointing stuff out to us. So I think that community is really special. I think the open source part of it is very special. One of the main things as well is like, if you're thinking, okay, am I going cloud or am I going core? A lot of that depends on like the amount of customization that you want, and sort of that time to delivery. Like if I like cars, so I'll use a metaphor. Like, you can buy a car at the dealer, and they will support it, and you have that warranty. But if you go home and you modify it, and you want to do all this modular stuff, and put different parts on it, and I don't know, you want to have a big, loud, flashy car, like the dealership won't fix it anymore for you, won't support it. So I kind of see it in some ways like that. Like, and for the most part, right, there are companies that we've had that say, I need this functionality and I'm actually going to write my own package for it. So for that, I need to use DBT Core because I need the most modular experience. I need the most control. But the vast majority of use cases really don't need that. And the trade-off to having to support all your own infrastructure, all your own orchestration, your own Git setup, it really, really depends on the people that you have, right? The personas and the skills that they know coming into that. So if someone's never used the command line, right? They've never used CLI, that would be really, really tough. And that curve that we've really tried to flatten that you've talked about, like it just spikes right back up, right? And so I think that's one of the things. When we think about the implementations that different organizations need, it really is like you have to look at the use case that you have and what you need out of that.
I see combinations actually, like in very complex organizations who want to roll out DBT, I see a combination of core and cloud. Like core for these, as you mentioned, there's super niche, hyper-tailored processes, even steps within continuous integration flows. They're so specific. People who know that they want that kind of requirement, typically they know how to deal with open source in a governed way. And so they want to play around with that. They know how to organize it. We can't take it away. But those people, they're like the 1%ers. And it's not the people who are going to do the vast majority of data transformations. But those people typically don't care about like whatever Jenkins is doing or GitHub Actions is doing in their custom modules. They just want to create more data sets. And they don't even want to care, as you said, about the terminal and command line and the different options that CLI Git has. They just want to push their code into some repository so that their product owner can check the validity of it and then move it to production.
Yeah.
Yeah, sorry.
No. You finished. I want to make sure.
Yeah, so what we see often is that DBT Core is used for like these hyper-tailored niche use cases, but DBT Cloud is used to scale out. I like to make sure that people who actually don't care, and they don't have to care about all of these super specific IT things, they still can contribute to larger data projects in a very meaningful way, at the same quality even.
And I think it's also like, these can sometimes be the same people, right? So like, okay, you have power users that, and when you think about data engineers that want to reduce that time to delivery, yeah, they can definitely be using cloud. And then when they want to experiment, going into core as well. And once again, I'm a person of metaphors. A good example of that is like, yes, I have a MacBook, right? And I send emails and I do that every day. But especially around the holidays, I like to get Raspberry Pis and think about sensors and build my own clusters. But that's not what I'm using to send email. And I think so. It's not just that, oh, here's the super technical people and here's the not technical people. It's like, no, data engineers that want to empower their analysts and have that reduced time to delivery will also be using cloud. And I think that's an important distinction. And just like not wanting to think about certain things day to day, or have more, having more parts that can fail when you do everything custom as well can, you might want to shift away from that.
I haven't thought of that, but actually you're right. Huh? So on the Raspberry Pi metaphor versus the MacBook metaphor, so DBT Core, the open source thingy, is where you play around, where you experiment, and DBT Cloud is what you use when you dive into, we're in Europe, regulated data sets. And so DBT Cloud will not allow you, for example, to see unmasked data if data masking is properly set up in combination with Snowflake. Whereas if you use DBT Core, you get access to whatever credential you can get hold on. And yeah, indeed, yeah. If the MacBook is DBT Cloud and that's your really working environment, where if somebody is looking over your shoulder and making sure that no mistakes are made against policy or governance is properly held, cloud.
Yeah, and like I know data science, but I don't know cybersecurity, right? So who knows what my Raspberry Pi cluster, when it's on, what traffic I could be getting. And I think that's like a really good point when you think about GDPR, when you think about healthcare data, specifically in the United States, healthcare and financial data. And making sure what Snowflake and DBT do together is making sure that all your logs and what's actually been run, like that's all scrubbed of that sensitive information. And because the data is not being moved when you use DBT, you don't have to essentially you don't have to have another compliance check in place because the data is not actually being moved anywhere. So I think that's also a really good call out when you're thinking about cybersecurity and compliance and all the laws around this, to make sure that your analyst doesn't have to worry about the issues with de-identification and possible data leaks around that, or data snooping issues for sure.
For us in Europe, it's an important one. So data movement is discouraged, and especially data movement outside of the European Union is frowned upon and basically heavily regulated as well. So we are particularly interested in making sure that Snowflake and the Snowflake contract is compliant with our current laws, and that whatever technology we put on Snowflake does not move data out of Snowflake. It's cheaper to not move data out of Snowflake, but especially important to make sure that all of the processing happens on Snowflake. And you see a lot of trends in the Snowflake ecosystem moving in that direction and making sure that logic is defined somewhere outside of Snowflake, but Snowflake doing all of the processing. I think it's a very interesting trend going on at the moment.
Yeah, and I think that's also what Snowpark was looking to do with filling that niche, just to sort of demystify some of the buzzwords here, right? Like Snowpark is essentially this API framework that allows you to run Python, Scala, and Java directly on Snowflake. So this is, to your point, like, what did this look like before? This looked like having to move your data to different places to have those runtimes. So like if Python wasn't supported, so you would need to move the data out of Snowflake in an environment that could run Python. And so when you take away those issues, and that's where it's like, okay, is data work getting harder because we have to think about more things? Is it getting easier because the technologies make it easier for us? As an end user that plays around with this stuff, the fact that I can switch languages between SQL and Python within my DBT project pretty seamlessly, and it's essentially running it in the background for Python as a stored procedure, like it's interpolating all of that, and all I see as the end user is my new table gets created from the code that I've written. So I think that's one of the things that's really powerful as well, is like seeing a movement in reducing, I shouldn't call it a movement, seeing a trend in reducing the data movement makes it a lot easier. Yeah, and sort of just like going back to like, what business problem am I solving, as opposed to like making everything a technology problem.
Yeah, indeed. I'll try a metaphor myself. It's actually like building the iOS for Snowflake that you guys are doing.
Yeah.
Super accessible layer that allows you access to everything underlying that's super powerful, but you don't have to care about the details.
Exactly. Yeah. Do you want to talk about data personas? I feel like we've been like coming around this topic, right? But it's like, okay, we've been talking about analysts, we've talked about analytics engineers, data scientists, machine learning engineers, and like, whoa, right? Like the Harvard Business Review article about like data scientists being the sexiest job of the 21st century came out like 10 years ago, and I think so much has changed since then. So like when I think of my data engineer, and a lot of people migrating from data science to data engineering, so when I think of my data engineer, I'm thinking of somebody who wants to make all the data available as much as possible and as productionized as possible. So when I'm thinking engineers, I'm thinking of people who care about productionizing things. So the analytics engineer is in there as well. So like, what are they productionizing? Analytics. What is the data engineer productionizing? Data. What is the machine learning engineer productionizing? It's the machine learning algorithms. Then you have really like the research scientist, the analyst, and the data scientist. And I think these are more ambiguous, hypothesis-driven types of roles. And so like instead of, and like I said, you see people shifting from data scientists to data engineers. I think there's a couple things. It's that not every personality is suited for like the ambiguity. Maybe you don't want to do hypothesis generation. Maybe you want to build, and sort of respecting those different personalities in the workplace. At the same time, I think there was a huge infrastructure deficit while companies wanted to do data science, but they didn't have any data engineers. And this pushed data scientists to have to learn essentially what 5 data engineers would do just to be successful. So I think it's like, I think that's why we're seeing some of those roles and some of those role changes. And it's not something to be frowned upon. It's really just, it's the evolution of the data industry. Would you agree? Yeah.
I don't know. It's an interesting question. We don't face it that much, but we're starting to see a huge consolidation wave into Snowflake. Like people who are data engineers by trade, people who are data or machine learning engineers by trade, like much of the activities they do on a daily basis are getting too expensive. Or like managers or budget holders, they're starting to realize that much of these things these people are doing, they are not directly contributing value to solving a business problem. It's just making sure that the business problem has basically this table to be solved on. And these things are being cut away. These things, Snowflake automates these things. Snowflake is very vocal in automating these things. It is the Snowpark integration that you said. It is the support that dbt is now offering for Python in combination with Snowflake. It's basically optimizing or making the day of a person who is adding value to a process more valuable, getting more value, squeezing more value out of it. Yeah.
And I totally agree. I also think I'm excited to see where dbt goes with this Python stuff, as far as having more data scientists and machine learning engineers come into the mix for kind of a territory that was really mostly analytics engineers and data engineers. So I think for me, I want to see where the Python journey goes with this specifically. And like good feature stores are good feature stores, right? Like good clean data everybody needs that as a starting point, which is why I think like, it doesn't matter what your role is, coming into that dbt framework could be beneficial really if you're working with data, which is a lot of people now. Everything's data driven in some ways, and some ways it's not, but yeah.
Over the past few years, dbt basically drove the concept of data ops, I think, to call a buzzword, with data integration. And you folks now have started releasing Python integration. My guess, my hope, my prediction is that MLOps will be next. I like that.
Yeah, that's something that I've talked with some people on our product management team, and what you can kind of do today is almost build like a slim MLOps. Pretty much as soon as Python got supported and released at Coalesce this past year, the Coalesce conference that dbt hosts, people were essentially saying, hey, can I use this to automate all my machine learning pipelines? So I love seeing people, when something's released, and really just pushing it from the start and wanting to use it in the most productionized way. I think that is such a far cry from when I started data science, that it was like, let me just get this proof of concept done to like justify data science existence at a company. And so the sort of like push for, okay, deployment is how I'm going to have business value, right, is great. I mean, there's some insights that maybe they're more strategic. They don't need to be updated like the way that a workflow needs to be run. But that's where you see those research scientists and data scientists kind of having more of those insights that are like, they're really big, meaty insights, but they help dictate like the roadmap and strategy as opposed to, is this customer going to churn, right? So like the cadence of the problem has changed as well. And there's no reason though, if you need to repeat a proof of concept, that was probably like my biggest nightmare. Any data that's like, oh, this looks so great. Can you do this at scale, or could you repeat it later in the future? I can't. And so I think even some of that stuff, like unless you know it's going to be a one and done, it probably belongs like in DBT. It belongs in Git. It belongs in Snowflake, right? Like just to track your own work. So I think like that's something that's exciting is people want to productionize their work, whereas before it was like, oh my gosh, I don't even know how to start. Isn't the software engineering team going to do that for me? So I think that's such a cool direction that's gone.
Definitely. And no one is going to make a career if their work isn't going to production, and no one is going to get a budget to do a new project when the last few ones were not successful. So operationalizing and reducing the time to market for like more complex use cases, it's a big performance improvement.
Sure, for sure.
Hope it feels like we could go on forever on this topic.
I know. That's what happens. This used to be a joke. You put a couple of former data scientists in a room, and what happens. But like, it's been so lovely catching up and talking, and I love discussing this stuff.
Indeed. We should catch up later on, but for now, I'm going to wish you a great start for your day. We're taking off here, and let's catch up online in the DBT community.
Perfect. Thank you so much. Have a good one. Bye.
Have a great one. Bye-bye.